2018, Day 6, Part 1. Chronal coordinates. The device on your wrist beeps several times, and once again you feel like you're falling. Situation critical, the device announces. Destination indeterminate. Okay. Chronal interference detected. Please specify new target coordinates. The device then produces a list of coordinates, your puzzle input. Are they places it thinks it's safe or dangerous? It recommends you check manual page 729. Elves did not give you a manual. If they're dangerous, you can minimize the danger by finding the coordinate that gives the largest distance from the other points. Using only the Manhattan distance, determine the area around each coordinate by counting the number of integer XY coordinates that are closest to that coordinate and aren't tied in distance to any other coordinate. Your goal is to find the size of the largest area that isn't infinite. Okay. So we have a bunch of coordinates. The actual grid extends infinitely in all directions. I see. So A is got a point that's got infinite coordinates because it goes off the edge. And the same with C and F and B. But E is confined and D is confined. Okay. And then we just have to count up how many points there are that are in the confined area. All right. It seems like we could just do a brute force approach to this, right? Scan every coordinate, find the point that's closest to it. How can we determine whether or not a point is infinite? And then we can ignore it. I guess what we can do is say if it has a point on the edge, maybe we can do that and say, if, for example, A and C and F and B all have points that are on the edge of the grid. Yeah, we could do that. So let's say get input 2018 day 6. There are 50 lines, there's 50 points that we have to consider, and they all seem to be relatively small values. This is just the first 20 of them. All right. Let's create our template. Let's create that. Oh, I want to jump to it real quick. 2018 day 06. Right. Flip back. And that way we can create this and add this on here. If we go here, Clippy is not complaining. And if we run it, it should say unsolved. Perfect. All right, so we have our template set up. Let's commit that. Git commit. Oh, git add source. Because we have a new file. Git commit -m 2018 day 6 template. Yeah, Mohad says, how would you know if an area is infinite? So yeah, that my first guess is going to be just look to see if it has a coordinate on the edge. So let's create our what we do is we can just define points, right? Let's create a struct point with an X and a Y. And I'm going to use I64 so I don't have to worry about negative numbers, but I've got a feeling that these are all going to be in the range 0 to something. And this is just going to be what are these called? Yeah, they're just called points. Okay. Sometimes they have like satellites and things like that. So vec point. And all we have to do is read them in. Let lines is equal to, should we use test input to start out with? Yeah, maybe. Let's use test input. And then we can go read the file later. Let's see. Oops. Didn't want to increment that. Right? I do this, close it up here. It all fits on one line. And now we can just parse, right? For L in lines, self points, push, point, parse L. And L is a stir, okay. Impl, point, fn, parse, p, which is a string, returns a self. Let xy equals p dot split once, comma space, unwrap. And then we can say let, we can probably just say self x parse unwrap, right? And then do the same thing for y. And then in part one, let's just dump them out. We can see them. Let's add debug output to this. Yeah, so we have the 1, 1, 1, 6, and so on. All right. So as we are, so I want to get the extent of the area, right? We can see this goes from 1 to 9, but the test input, the actual data input has the Mohad says you don't like to use from stir or whatever the trait was. That's a good question. Would that be a more rusty way to do it? Because then I'll definitely do that. From stir. It's a trait method. So if I impl from stir, then it gives us a result. So we can even say, we have a parse error. Yeah, then we have to deal with the result. Let's try it. Why not? Impl from stir for point from stir. And this is going to return a result of self or self : error, right? Which is a type. I have to do it like that. And this is okay. And I can question mark these instead of unwrapping them. But then the error case is wrong, right? Yeah, can convert the error to string. So what is the error actually? Parse int error. Okay, so we can make that. And import that. There we go. And now we could just say from stir. And then we'll have to unwrap it here. There. Okay. They even have an example of point, do they? Oh, how about that? How about that? That's exciting. All right. But so this is how you would do it with my version of it. Actually, the unwrap. Ooh, yeah. See, this unwrap might fail too. We can't just do that because we can't. We can map error. Let's if we change this to string, right? If I put this back, what's the actual error type here? Let's go over here. Use OK or to provide an error compatible. Yeah. So OK or input file corrupt. Let's see if it'll convert that. Oh, I have to say toString. Oh, or I have to question mark it. There. Yeah. And this is Well, does parse return a result? It does. Okay. So I can say okay or x value corrupt. Actually, I can format that, right? To stick the y value in there. Oh, it doesn't like that one there. But see, by doing this, then I can put this kind of thing in the library, right? We can move this point into the library, and that way we can make it more friendly. Split once returns an option, and that's why you can do OK or. So this should be unwrap or. Nope. These are stirs. The example does map error. Okay. Which takes a closure. Okay. How's that, Mohad? And then we'll fix up this X and Y business in a bit. Yeah, and then this whole thing can move into a into the library. All right. So with that, what we can do is we can also have a min point and a max point. And that'll define the bounds of our rectangles from 1, 1 to, it looks like 8, 9. And we'll just, as we parse them, we can keep track of the minimum and maximum. And we can add that to point too, right? Let self min equals p dot min of self min of p, and max self max of p, and then we can say self points push p, right? And then we can add those. Impl point min self other point and self, right? I might be going overboard on this, but that's fine. And then self x min other x. This is generating a lot of objects as we parse through the file, but there aren't that many. And next, Mohad, you're going to tell me that there is a min and max trait that we can implement instead. Oh, okay, default, sure. Oh, self min and self max max. That's bad. And then borrow. No, I actually am genuinely curious because I'm using Rust to learn. And if I'm not doing new stuff each time, then I'm not learning. So if there is a better way to do this, then I'd be happy to do it, because then we could actually have a closure, right? We could do self. We could say after we push all the points, we could say self min is equal to self points iter min unwrap, right? Instead of doing it inside the loop here. And we'd be calling min on it. I could do min by key, p for point, and then p dot. Yeah, but then how do you? What do you put in here? Anyway, I think this will do it. Println min point equals self min, and max point is self max, right? 0, 0, and 8, 9. 8, 9 makes sense. 0, 0. Oh, because min is starting off. Yeah. Oops. So maybe min needs to be in a second loop. What's a good way to do this then? Because we want to set min to the first point, I guess, if it hasn't been set yet. But we don't want to just check for 0, 0. Mosfo said you can initialize min to some large number. Yeah, but then that would be specific to that value, right? Say I set it to 50, 50, and the real min was 80, 80, for example. I could set it to uint max, uint 64 max. That's not a bad idea. Self min dot. Do I have access to this? Is 64. I think it's max. I think that's the way you write it. Didn't complain, and now I have the value. Yeah, and then I was thinking that malfeaturebin of making it an option, but then I have to unwrap it everywhere, and that gets annoying. And that's why it would be nice to be able to just write a little trait for it, right? Because the trait that the iterator would handle that issue for me. Anyway, I think we have it, right? We have the minimum and we have the maximum. And now we just need to go through every single point in part 1. For x in self.min.x dot equals self.max.x. And for y in self.min.y dot equals self.max.y, right? Tommy says, you on day 6? Yes. Mohad says yes too. Einav, thank you. Welcome to the channel. Hello. Okay, so we don't need this business. What are we even trying? Oh, that's right. We're trying to determine what area is enclosed by, what's the size of the largest area that isn't infinite? Okay. So what we need to do is store for every point which point is it's closest to. And I'm seeing this here. Locations shown as dot are equally far from 2 or more coordinates. So they don't count, I guess, as being closest to any point. Okay, so that's good. Einav says, what are you making? I am working on Advent of Code. If you do bang AOC in the chat, or if you look at the chat description, you'll see a link to what I'm working on. What do we got? Let's create a hash map, which contains the nearest points. And what will this map? This will map the count, the point coordinate, the point name, which is just going to be one of these guys, one of these points, to a count. Right? So we loop over all the x's, we loop over all the y's, and then we're going to loop over all the points for p in self points. And we're going to figure out which point it's closest to, and then add that to the hash map. So it'll be map.insert, so the closest point equals, I don't know, point x0, y0. I can just say point default, right? And then dist is equal to, oh, what's the maximum distance can something be? Would be the size of max x max y minus min x min y would be the maximum. Right? Because we're looking for something that's the shortest. We could just say self max x plus self max y. That's going to be whatever min is. This is still going to be larger than the distance that we have. iNav says, is this a coding competition? It is, but it doesn't start until December 1st. And so I'm just doing this to warm up for it. They have one for every year. If I go back over here, look at Advent of Code events. You can see they've been doing them since 2015, which is pretty cool when you think about it. You know, this is the 9th year. Next year will be 10 years of Advent of Code. Right? Anyway, so we're working on 2018. So once we have the maximum distance, what we can do is we can measure our distance to where we are now. We can say let, well, let's call this max dist. Right, and we can say let dist equals p dot dist of xy. Right, and we can implement that. That's easy enough. It's just the differences, absolute value of the differences summed together because we're doing Manhattan distance. Self x minus x abs plus self y minus y abs. And that's our distance. And we say if dist is less than max dist, then we're going to save our closest point is equal to p. Might have to add copy and clone. And then our max dist, oh, this should be min dist. What am I thinking? Dist is dist. And then when we're done, we found a point. Oh, no, we want to say map entry for this point. Or default 0 plus equals 1. No. We want to check to see. We also, I'm missing the part where we check for equality. Yeah, so we could just say insert closest. XY has closest point. Right? We still haven't done it yet because we have to check for equality, but we're getting close. This is min dist. All right, it runs. We can get rid of parsent error now. Okay. And now what we can do is we can, so we still have two more things to do. We have one thing to check for equality and one thing to check for infinite distance and ignore the infinite distance ones. So maybe we want to extend point and say point has data associated with it. And call this infinite false. Same there. And same here. And then we'll just tag it, right? If we could say, oh, this is on the border. So we can say if x is equal to self min x, or x is equal to self max x, or y is equal to self min y, y is equal to self max y. Ooh, that fits on one line. Then we can just tag, oh, this is a copy of it. Yeah. Okay. So maybe we do this, a reference to self points of 0. And then this becomes a reference. So now we can modify it directly. Closest, oh, I don't know if this is going to work. Closest point, infinite is equal to true. We might have to loop differently because, yeah, because we're closest point is a reference, and so I wouldn't be able to. So I can't do this and then have this loop work, right? Right, because I then I'll have two things that are mutably borrowing it. So I think what I need to do is say for I in dot self points len, and then I can say self points I, self points I, right? And then closest point is going to be negative self points len. All right, well, instead of doing that, we'll just save I. Self points I dot infinite is true. Closest is hard to type. All right. Still unsolved, and we still haven't dealt with equality, right? Right. We have to say else if dist is equal to min dist, then we don't want to include this point at all. Are we going to have to do a found? Let mut found is false. Found equals true. Found equals false. And then once we do all that, oh, this is not going to work anymore. If not found, continue. This is getting uglier and uglier. Okay, so now what we do want to look through is the value and what the values, and what is it? The largest area that isn't infinite. Oh, we can do that straight up. Right? We can say, instead of doing this, we can say vecbang 0 use size self points len, and then just increment that for the point. Map of closest point plus equals 1. Right? And then we just look for the largest one. Map.iter.max.unwrap. 17. Is that what the 17? Look at that. Got it right. Okay. So now we try it with the real input. Oh, right. That's what I want to do. Input here. Let lines is equal to AOC lib read lines input 2018-06 text. Oh, this is a vec of strings now. So we can just amper that. 8170. Let's try 8170. That's not the right answer. My answer is too high. Dang it. All right. What did I do wrong? Well, let's think it through here. We're looping over all the points, right? For x and for y. We're ignoring we're just doing that. It doesn't matter what it is, right? The min dist is going to be this, right? Because we want to set it to a larger value, and we want to see if we found it. We loop over all the points. We look at the distance from xy to the current point. If it's less than our minimum distance, then we'll save it, and we say we found it. If it's equal to, then we didn't find it. After we're done, if we didn't find it, that means the last thing was that it was equal. So we ignore it. We don't include it in our calculation of our size. Right? That's where the dot comes from. If we're on the border, then we're going to declare, oh, I forgot to check to see if it was infinite. And we have to set self no, we have to say map closest point equals 0, else if not self points closest point dot infinite. There. I think that's what the problem was. And now we don't need hash map. Now we have 3907. That's a smaller number, right? Hey, okay, so that was the bug. Mohad says, your idea is smart of checking the borders. Well, I mean, it could have backfired. Thank you, but it could have backfired. Like if there was like a point where like maybe C hit the border here, but maybe that was the last point and then some other value took over outside of that. But it seems to be working, at least for my input, right? So I'm going to call that a win. Is there anything we can do to make this cleaner? Does Clippy like it? Clippy does not like it. If chain can be rewritten with a match. So it's suggesting doing this. Match dist dot compare to min dist. This is what it's suggesting I do. Right? And of course, that was it. 3, fill match arms. So if it's less, then we do these. If it's equal, then we set found as false. And if it's greater, we ignore it. Is this easier to read? Clippy likes it. Does it give us the same answer? That's the question. 3907. It does. So I got the less and the greater in the correct order. I don't know if this is easier to read. Can I replace qualified path with the use? Yeah, let's see if we can do that. Okay. I don't know. It seems like the if statement works better to me. Anyway, because it's clearer what you're trying to do. But I don't know. Clippy seems happier this way, so I'll just stick with this way. Yeah, it just seems awkward. All right, git status, git commit dash AM 2018, day 6, part 1. All right, let's take a look at part 2. Oh, I went back instead of, continue part 2. There we go. On the other hand, If coordinates are safe, maybe the best you can do is try to find the region near as many coordinates as possible. For example, suppose you want the sum of the Manhattan distance to all the coordinates to be less than 32. For each location, add up the distances to all the given coordinates. If the total of those distances is less than 32, that location is within the desired region. Using the same coordinates as above, the resulting region looks like this. Because the total distance to all coordinates 30 is less than 32, the location is within the region. We're talking about this one location here, right? So we want to scan all the points again and add up the distances to each point. And if the distance to each point is less than 32, where was it? Less than 32, then we're good. Then we include it. Otherwise, we don't include it. So what's this? Why is the region containing all locations which have a total distance to all given coordinates of less than 10,000. Okay. All right. Let's do this with our test input again. There we go. So we're going to switch this back. And then part 2 is just going to scan all the coordinates again. So we're going to say for x in min self min x dot equals self max x, y in self min y dot equals self max y. Now we're going to loop over every point and add up the distance to that point. And if it's less than 10,000, then we include it in our total. Right? So for p in, this time I think I can do it this way, self points, because we're not modifying the point information. I guess I could clean that up above by having, instead of storing the infinity inside the point itself, we could make it have a separate array, but that's fine. So now we want to add up all the points to this current point, xy. And if that distance is, okay. Actually, so what we can do is, let's say total distance is equal to self points iter map p dot dist xy sum. Right? And it's unknown. Why is that unknown? I'll have to give it a type. I64. So all the p dists are I64s. I don't know why it can't infer that, but it can't. All right, so now we say if total dist is less than 10,000, total plus equals 1. Or we can say total plus equals this as I32. And then just return total. Oh, right, I have to change that back. Why aren't these stirs? Oh, it's because I'm doing this. Okay. Nope, that's not it. Dang. I thought it was. Run. 72. What was the actual answer? 16. Okay, so this failed in a big way. What did I do wrong? Oh, right. This one is a different number. This is 32. Okay. 16. There we go. All right. So 10,000 only works for the real input. Let's see what happens. 42036. Yeah. And Mohad says, wait, what's that? A condition in the middle of an assignment? Yeah. So I'm kind of cheating. This is a Boolean expression, right? But Booleans can be cast to numbers, zeros and ones, just by putting an as there. So I did as I32 because this defaulted to I32. And then it just adds them all up. It's essentially saying if total dist is less than 10,000, total plus equals 1. All I'm doing is I'm casting this true value. If this is true, then it casts it to a 1, and then I just add it. Otherwise, it casts it to a 0. And it still adds 0, but adding 0 has no effect. Right? What does Clippy say? Clippy's happy. All right. That was an easy part 2. Usually part 2s, I guess, if you have your data set up properly, the part 2 goes faster because you've done all the work of reading the file and parsing it. But there have been part 2s that have murdered me. Mohad says, don't you think it makes the code less readable? Yeah, right. If it's a similar argument to this thing here. If you're familiar with this style, right, then this is going to be pretty obvious to you what's going on. You're comparing it on, and if it's less, you do this. If it's equal, you do this. If it's greater, you do nothing. Whereas using the if statement here, to me, because I'm more used to the if statement, is more readable. This, if you're not used to it, takes you a minute to figure out what's going on. But once you get used to it, it's I can see an argument that says even if you're used to it, it still adds a little bit of friction. It would be nice to be able to do it with a filter, right? Have this generate all of the total dists and then just filter them and then just do count. We're going to leave it like this. This one works. Yep, this gives us the same answer. I haven't broken it. Yeah, and this was a pretty straightforward change, right? I don't know what I was doing up here with the, I don't know why I can't get that to work both ways, but I can't. So git status, git commit dash AM 2018, day 6, part 2. All right, it's 8 o'clock. I got about a half hour left. This took an hour.